Um, a very good afternoon to everyone. This is Sushant Singh from PT department, and under the course of Advanced Energy Technology, the AET assigned to me was biogas upgrading technologies from waste to clean energy. Here we could see the quick opening parts like defining the scope, short overview that will cover the way, the why, how, the techniques, the applications based on it, and the real project assigned to it. Next slides, what we have is why upgrade biogas? The question arises, why can't we go through the traditional methods or the existing conventional methods present for the biogas? Here are the points. Why should we upgrade biogas? Raw biogas has 50 to 70% of methane plus CO2 and trace gases. Upgrading concentration methane to biomethane, that is more than 95% of methane for higher value use, such that higher yield will be there. Enables injection into the natural gas grids, uses vehicle fuel, or you could say a kind the conversion to the more usable and high efficient way. Reduces methane emissions. That is a very potent greenhouse gas and could be eco-friendly. Next is overviewing of main upgrading pathways. There are considered as many pathways, out of which I have considered five, uh, out of which I have taken physical chemical separation, which is water scrubbing and chemical scrubbing. Next was membrane separation, that is polymeric multi-stage. And I've considered cryogenic separation, which is nothing but a kind of a cooling system for biogas furnishing. The first one is water scrubbing and physical scrubbing. The principle here is CO2 is more soluble in water. Biogas contacts water under pressure, so CO2 is absorbed. The positive aspect of this pathway is simple, robust, and relatively low capital cost, and medium scale is suitable. The negative impact occurs, water consumption is very high, and if it is used for certain chemical reactions, it needs to be treated, so there will be additional cost. Fugitive methane loss is possible, so the efficiency might drop down. Typical uses like in a farm scale to the mid-scale plant supplying local grids or CNG compression. Next, we have membrane separation. Membrane separation, as the name itself, it says that the permeability of a substance, as we're talking about gas, is rectified or look in between. Selective permeability, methane passes preferentially through polymer membranes. Often, 2 plus stage trains to reach more than 95% of methane. Positive impact of this pathway is very fast and low chemical use compared to the previous one, the chemical scrubbing. The negative point occurs sensitivity to contaminants and hydrogen sulfides and liquids, membrane replacement cost, and some methane slip. Okay, so best for modular or distributed plants, retrofit to existing digesters. Last but not the least, pathway is advanced hybrid solutions that has cryogenic and catalytic power to gas. Here we could see cryogenic is like a cool gas to separate CO2 by condensation suited to large volumes where refrigeration is economical. Okay. So catalytic methanation or biological policing, we could say, converts CO2 plus H2O to methane, that is power to gas integration. Okay. So hybrid combined membranes plus PSA or scrubbing or PSA to reduce energy use and methane losses. The hybrid system is considered to be the more efficient compared to the other one. Uh, so out of this, I have taken what I consider would be this pathway would much more be functional and efficient than the previous two. Okay. Next is s- seeing all those pathways in context to the world. Uh, Lots of projects has already been initiated. For example, Gasum's acquisition and upgrading in Denmark, Scandinavian, large-scale agricultural manure to biomethane plants with upgrades and grid injection. I'll tell you about the grid injection in later slides. Here we could see the Netherlands, Gasunie, green gas and infrastructure investment, large investment in biogas, biomethane infrastructure, and green gas hubs. Could also be seen. India, in other hand, we could see um, compressed biogas. Okay, CBG is nothing but compressed biogas rollout, HPCL, and it's a SATAT initiatives, national programs and major corporate investments to build dozens of CBG plants for transport, fuel, and industry. Um, and similarly, European Gas Association has also been there in biomethane plants and all construction. Yeah, grid injection, what it actually means is here biomethane sold as a green gas to household and industry. So it basically is like the conversion of a raw form of a gas in a more usable form, or you could say in a biomethane form that could be, you know, could be used in a very multidisciplinary way instead of just one because of its change of its state. One could utilize it in other sectors too. Example, in Netherlands, as we mentioned before, Gasunie operates national gas grid and invests in biomethane hubs to inject upgraded gas, ensuring it blends seamlessly with fossil natural gas while carrying renewable certification. Correct. The thing is, the existing fossil fuels, the natural gases, and the formed artificial methane gases, the main motive would be the integration of it without any, unsuitable or unsustainable act, preventing those acts. Renewable transport fuel and on-site CHP and industrial heat and power, circular economy services are few business models or value that could be captured with the help of this biomethane integration. Of course, even after so many um, possibilities, we must, or we may, you know, feel or would occur some kind of a challenges regarding any kind of a construction or any kind of ideas that needs to be initiated. For example, in this context, we could see the key challenges like feedstock logistics, contaminations, and methane slip regulatory harmonization for grid injection, as we're integrating two new things, a kind of existing natural properties and that of a artificial concept. So that needs to be uniformly distributed or harmonized. Okay, policy labels, you could say tariffs. Okay, so tariffs in the sense, green gas certificates, feed-in tariffs, subsidize transportation fuel, industry investment. So economy is somewhere involved, and that needs to be cared. Other thing is practical next steps. What could be done practically, implementers and all those things. We could see, the PSA train, secure feedstock contracts, plant pre-treatment for contamination. This needs to be the prioritized in order to prevent further damage or loss to the construction or production of biogas integration, we could see. As per the global biogas market, you could see these are the this graph we could see in coming days 2032 the usage, you could see the usage is increasing, and the increment is like a municipal and industrial area and agricultural concepts, plus economy is like $71.3 billion. The concept what I am presenting right now is not just about ecosystem. Yes, it is very essential, but also the economic value of the country would be targeted. Therefore, this needs to be carried on or should be seen as a potential, possibility, and also minimization of the challenges for further development. Thank you, guys.